Hi, this is a report of a movie recommendation system from Fengliang Time and xinsong. Our report is composed of five parts: main idea and motivation, related work, data and algorithm used, result and evaluation, and finally conclusion. The convergence of computing and communication has produced a society that feeds on information. Yet most of information is in its raw form, that is data. Data mining is the extraction of implicit and previously unknown and potentially useful information from data. Machine learning provides the technical basis of data mining as well as other methods such as clustering and classification. We decided to make a practice of classification and prediction using supervised learning. So we intended to build a simple movie recommendation system based on memory-based master methods. Recommendation systems are best known for their use on e-commerce websites where they use input of our customers' interest to generate a list of recommendation items. However, these algorithms face many challenges such as handling the huge amount of data and giving the result in real time. Amazon.com has created an efficient one called item-to-item collaborative filtering, which produces recommendations in real time, scales to massive datasets, and generates high-quality recommendations. Traditional collaborative filtering is divided into two genres: memory-based and model-based. Model-based algorithms using modeling algorithms or machine learning, such as Bayes' believe-net clustering, makes pre-calculating for models offline and so quickly get the result in online. Memory-based algorithms utilize the entire user item database to generate a prediction. These systems use statistical techniques to find a set of users known as neighbors which have similarity to the target users. Once a neighbor is formed, this system will use nearest neighbor technique to produce a top-n recommendations. In user-based algorithm, to make a recommendation for a user, we calculate the weighted score by adding all the other users' ratings multiplied by similarity score for each movie that the user haven't seen. However, there are several challenges of user-based collaborative filtering algorithms such as sparsity and scalability. Item-based algorithm is almost the same as the user-based method, except it calculated the similarity between items. We choose movie lens as our dataset. The dataset describes 5 stars rating from movie lens. It contains more than 100,000 ratings and 1,296 tag applications across 90,000 movies. This data were created by 671 users between January 9th, 1995 and October 16, 2016. Generally, we have used 4 algorithms to build our system. The first one is to calculate the Euclidean distance score between person 1 and person 2 in an n-dimension chart. We take a difference in each axis, square them and add them together, then take the square root of the sum. We also set an adjustment to this similarity score like this. Due to the adjustment, we can avoid some extreme case. For example, 2 people both watch 5 movies and rated, but there is only one in common. The rating is the same. Without adjustment, the similarity score would be 1 because it only consider movies in common. However, that is not what we want. After the adjustment, the similarity score would be a little smaller than its original. The code for Pearson correlation score first finds the item rated by both critics. Then it calculates the sum and sums out the square of the rating for two critics and calculate the sum of products of their ratings. In item-based recommendation, for all movies the user have seen, we find that there are similar movies that the user have not seen. Then we multiply the ratings of the movies that the user have seen by the similarity of the similar movies. In user-based recommendation, first we find similar users using the similarity algorithm, and we use the total score to divide the sum of similar score and the result are rated score. Finally, we return movies with highest scores. We also set an adjustment to the recommendation. In results, Fengliang and xinsong both watched 10 movies and rated them. There are 3 movies that they both watched, so their similarity score can be calculated as follows. We can see after the adjustment, the weighted score, the similar score is a little bit smaller. Take Fengliang as an example. The movies from user-based recommendation are all famous movies rated by a large numbers of users. The movies from item-based recommendation always have the similar genres and stories with the movies that Fengliang have seen but might be rated by a few users. We calculate the like rating of the recommended movies. We can see from the result that for user-based system, the like rate is really high, while the result for item-based system is relatively low. We can see that the system using user-based collaborative filtering is much more better than using item-based one. However, this result may not be convincing because the sample size is too small. We should ask more people to evaluate our system. But we believe that the result would be optimistic. In conclusion, we know the basic idea on how to make recommendations, and we built a small, simple movie recommendation system and make adjustments to improve it. Finally, we make tests and evaluation. We learn a lot from this project. Well, that's all. Thank you.